Good afternoon. Thank you for joining us. Thank you for having me here in Auckland today. My name is Dan Rosnova, and I'm a program manager on the Azure Core team focusing on messaging. And I'm here today to talk about how we serve 3 trillion requests a week with Event Hubs, and how you can build services like that using the same stuff that we use, public Azure services. Quick update to the title, though. We actually serve 4 trillion. That's changed in the 3 months, I think, 4 or 5 months since I submitted the abstract. Yeah, a lot of growth in the service. It's an interesting service. It's fun to be a part of. And I'm here today to talk not so much about the service, which we'll do a little bit, but really about how we use Azure, just public Azure resources that you can get and use yourself to run a service that's really at a tremendous scale. So what is Event Hubs? This I actually, for the conceptual overview, really like to borrow from what they say about Kafka, which is an open source platform. Is anyone in here familiar with Kafka or heard of it? Okay, cool. And that is that it's a partition consumer messaging service. So what it really means is that it's a distributed streaming platform, which is, one, it's giving you sort of publish, subscribe semantics on streams of data. They say that it's similar to a queue. That's kind of a dangerous analogy to make, but that's fine. We'll just go with it, because this is literally from the Kafka documentation. 2, that it's giving you those streams of data stored in a fault-tolerant sort of way. And we're giving you good fault tolerance that I talked a little bit about this morning. That's a little different than having to run it yourself in Kafka, where you make that choice. And it lets you process those streams as they occur. So low latency, an important thing that's different than something like a queue is you can replay the events over and over again. It's a client-side cursor rather than a server-side cursor. And it's really used for 2 broad applications, or 2 broad types of applications. The first is really just moving data between systems, so as a buffer. And the second is then for doing like transformation and real-time reaction to events. So those are kind of, one's an integration sort of use, and one's a sort of actual processing, stream processing sort of use. When we look at the numbers for the service, they're pretty big. Last week it was actually 3.8 trillion requests. It goes up and down by a couple hundred billion a week. And that averaged out to 6.3 million requests a second in the hour that I'm standing here. And it's, I don't have my computer up, but it is normal time kind of in Seattle, so I always look at it around the same time. So in the hour that I'm standing here, it'll be about 23 billion requests going through the service. During the last week before this, our success rate on that was 99.9976 for the whole week. It was a little higher for a few of the days, but that was our average. So it's a very reliable, very high-scale service with very low latency. And we're getting all this not through any sort of special hardware or magic that we're doing. We're just using what's there in Azure, in the regions that are there in Azure, and it's in every region. So we kind of have to be there. How this all fits into how you're building applications and stuff like that is some sort of pipeline like this, where data is flowing from the left to the right. It's a telemetry pipeline. We use this infographic a lot. It's just kind of here to show this is how you stage things together, stitch things together. Again, I'm not here too much to talk about Event Hubs itself, or even these higher level concepts in Azure, but more about lower level stuff that we use and how you can use it. The one concept that is a little important to mention, because the Kafka stuff, the Kafka documentation doesn't get into this until much later, is that it's a partitioned consumer model. So even though it kind of looks like a queue to you, when you're sending to it, the data is going between partitions inside of it. So they're separate. The data is independent in each of those, and each of the partitions can just sort of have its own life cycle. So when you send data to it, generally speaking, you're just sending to the whole Event Hub. The data is just flowing in, and we're kind of partitioning it for you, just round robin across all of the resources. To read, though, and this is what makes it partition consumer rather than competing consumer, which we'll talk about in a second, is that if you have 4 partitions, like in this diagram, you need 4 readers to connect one to each of those to read the whole stream. Otherwise, you're just reading a subset. So this is the classic scale-out architecture rather than scale-up. Up has limits, and out pretty much not too much in way of limits. And when both us and when the Amazon people at Kinesis or the Kafka people talk about PubSub or publish subscribe, what they really mean in this context is that you can read the data more than once. You can have a lot of readers reading at their own rate, but you're not really routing the data or anything. So this is a little bit different than what you see in a normal queue. In a normal queue type system, you see something more like this, where everyone's sort of competing consumers. They're all competing for the same resources. Sort of classic queuing theory type stuff. Speaking of which, a great example today, how long did you queue for lunch? Right, that's the ultimate example to see what's the competing consumer model. In all fairness, there were 2 lines at most of the lunch places, so there's 2 partitions. So it's kind of the same analogy. But that's exactly like why that sort of thing scales. You know, you could either try to make the single line go faster and faster, which is what we do for our queuing services, or you can try to partition out and really have no real limit. So soft limits that affect your scaling, are really in the public cloud that we offer for Event Hub's 2 components. And the components have to do with throughput units, which is something you're purchasing or reserving. These are capacity reservation. They entitle you to 1 megabyte per second or 1,000 events per second per unit that you're purchasing. It's an hourly charge for it. And twice that amount of egress, of reading. So you can write once and read twice, and you've reserved this block of capacity for you. This thing about namespace wide, I won't talk about what that means, but really just means, like in a region that you've stood up event hubs, the throughput will go across all of your event hubs. If you hit your limit, we'll actually throttle you. We'll tell you, hey, you're taking too much. This is on purpose. It's good for both of us to know what the limits are, and also to keep you from spending more than you've already planned to spend. The other aspect that you'll see when you saw before, when we had the partitions up in the chart, are partitions. And they do have an impact on scale. It's not so much on throughput, it's on how much you're able to read. It's when you think about those 4 consumers reading, you have a degree of parallelism of 4. You have 4 separate processes, 4 separate machines reading. So when you're thinking about scaling out, you're thinking horizontal scale. And you choose this at creation time. There are reasons we don't let you change this. Anyone ever work with Mongo? Anyone ever have to reshard a database or change keys? It's the most pleasant thing on earth. Since we give you ordering capabilities with some semantics, if we let you reshard, we would change the ordering and chaos would follow. So really, you could think about it as partitions sort of equate to storage within our system. And that's actually the truth. I'll talk about that a little bit too. And a limit that we actually usually don't say publicly, since we're going to talk all about how the service really works inside, I'll say it now, is that the real limit is 5 megabytes per second per partition. We tell you it's 1 because it's an easier thing to explain than what I'm going to spend the next half hour talking about. So we'll see if I can explain it well or not. So how you scale at like a public scale or a smaller scale isn't very difficult. Going from 1 to 20 of those throughput units up to 20,000 events per second, just go into the portal or use the API and you can change your setting. We could do that right now. It's actually fairly fast to set up. I have a cool video coming out with Corey Sanders on Tuesday, I think, that shows doing that. Use the portal. It's easy. You're billed by the hour. You can move it up for 9 a.m. if that's when you have your busy time, or 5 p.m. or something. After that, you can get more capacity. We'll give it to you. As you get more and more, we have to be more careful about how we give it to you so that we're not letting people take too much resources from our system. We'll talk about those resources and why we chose these funny numbers and things like that. Beyond 20, it's blocks of 20. So you can have 20, 40, 60, 80, 100. You just call support, Azure support. You can do it from there. You can do it right from the portal. And they are in effect until you call back for support. So you can't, this one's not really designed for you to be able to call for an hour and say, I want 100 megabytes or 200 megabytes a second for an hour, and then change it back. And if you need more than 100, we did recently release an offering for EA customers where they can get a lot more than 100. We can talk a little bit about what that looks like later. It'll make more sense, I think, especially at Q&A if anyone has questions about that. If you have questions any time through this, feel free to just yell them out or put your hand up or something. I'm really here to answer the questions you have about how we as a product team use Azure, not really to sell you a product or something. So the dedicated capacity thing, like I said, it's much, much bigger blocks. It's not something to be taken lightly. You're not going to stand it up in the portal. It's like having your own region of Azure. Not quite as onerous. So if you don't know how to get a hold of us, we have an Ask Service Bus alias. It's askservicebus@microsoft.com. You can email us there. My Twitter was earlier. You can look at that. I'm not really going to talk about pricing, although I do like to brag about this a little bit. quick sample is that we have 2 tiers of this. We charge you that throughput unit charge, which is towards the top, and then we charge you per million events. It's 2.8 cents per million, which is a tough way to make a buck, much to my chagrin. So a good sample that I like to get, the minimum that you could buy if you filled up the pipe all month is that 1 TU, 3 cents an hour. It's going to charge $22 a month. These are all in US dollars. You could send 1,000 events per second with that. If you did that all month long, that would be 2.6 billion events at 1 kilobyte in size. That'd be 2.6 terabytes of data. We don't charge by the data size per se. We charge by the message. And so that messaging charge at 2.8 cents per million for 2.6 billion is going to be $73. So all said and done, for $95, you're getting a highly available PaaS service that's run for you that gives the characteristics we saw earlier about the level of availability. So this is pretty good. It's a pretty good deal. If you want to get to bigger, I know a lot of people say, hey, I'm a really big service. I need to do like 1 billion events a day. 1 billion's not that big, actually, in our terms. If you needed to do that in an even distribution of traffic, which is kind of unrealistic, but just to make the math easy, that'd be 12,000 events a second spread out over the day. At 3 cents an hour per TU, that's going to cost you $8 and change. The messaging for that is going to cost you, for about 1 billion events, $20, $29, $30. And so all said and done, you're at $37 for a day for 1 billion messages, a terabyte of data. It's all sub-second, end-to-end. So it's pretty cool. I mean, if you find a cheaper, faster, more reliable service for doing telemetry, by all means use it. I mean, and let me know about it, because I'll use it too. But really, I don't really care about the money part, and I'm not really here to talk about that. What I am here to talk about is what we use and how we use Azure. The stuff that we use is all public cloud services. We use worker roles. Event Hubs came up in Service Bus. We were originally, and still are, part of that team. And all of our stuff was hosted together. So we're using cloud services because that's what there was 6 or 7 years ago when we started. And it's working really well for us. We're using blob storage. That's our data store. We'll talk a lot about that quite a bit. We're using a little bit of Premium SQL Azure for metadata. We'll see where that comes in too. And we're actually using Service Fabric, which we've been using for a very long time, since we launched Event Hubs 2 years ago, which was actually 2 years ago Friday, I think. And so this is a Service Fabric MSI. It's something some of you can probably download and use. I don't know if that's fully public yet. It's been something we've used inside of Microsoft for a long time, and a lot of services use it. We install it on the worker roles when they start up. It's all headless stuff. We'll talk about that. So those are really the big moving pieces here. There are a few other things for like telemetry type, billing type stuff that are used by all Azure services. So like that's the stuff you wouldn't be able to use. But if you need to do telemetry, you could use Event Hubs for that. We do in Azure. So how does it look like when we deploy this? We deploy kind of using a scale unit or stamp model. That's what we refer to it internally. What that looks like is that we've got some Azure networking set up that's hosting a VIP, so a virtual IP that's stable for the cloud service. We've got a set of cloud services for our front ends. We've got a second set of cloud services for our back ends. The front ends are stateless. These are TCP. This is just what you talk to use the service. The back ends actually do the real work of organizing the data and buffering it and flushing it to storage. This is where we have the Service Fabric ring running, is on the back ends. And then after that, we're using primarily blob storage, page blobs, to store your data, a whole lot of them, and SQL Azure to store metadata. So what does that mean for how does an Event Hub that you create map to what we are deploying? This is kind of a very simplified diagram of how we physically deploy. It basically works like this. You create an Event Hub. We're putting some metadata in a SQL database to say, hey, this is what it is, its identity, this is how many partitions it has, these are how many consumer groups it has, things like that. We are then deploying onto our Service Fabric cluster an application, or deploying into an application that's got what I've called in here containers. They're really, the Service Fabric term, which is my sister team, is partitions, but I don't want to use the same term for 2 different things in the same talk. So we're just going to call them containers. You can think about that's exactly what they are. And your partitions go and sit then in those containers. So the more partitions you have, the more we'll stack in individual containers. The throughput limit on a container in our public service is 5 megabytes. That's where that magic number 5 came from a few minutes ago. So this is kind of how it works. And then that's the runtime. The Service Fabric Ring is giving us a lot of availability. It's able to move stuff around for us on that cloud service. And then the storage itself is that we're using blobs for each of the partitions. We're actually using a lot of blobs. It starts at 1, and then we use more and more. They're in 32 megabyte blocks, basically, you could think about it, or chunks. So this is how that maps over. And then importantly, some kind of important stuff is once we've read all that metadata and stuff out, once we've created the Event Hub and the first time you've accessed it, we've actually cached that all in our cluster, so we don't have to keep going back to the database to get that information. So even if SQL Azure were to go away until all of our nodes start rebooting, which just happens over time and stuff, we won't actually have an outage. Like, we don't need the database there to do the runtime of the service, really kind of just the boot or load time. Some of the key characteristics of this architecture, like I said, once the data is loaded, it's cached, it's in the memory of the VMs. The Service Fabric container always owns every partition. This is one of the things that Service Fabric is giving us that's a little bit more advanced than something like Zookeeper would give you, is that you're actually getting an orchestrator to really decide who's going to own what at any given time. The load balancing in Service Fabric is pretty good. It lets you do custom load balancing, so it's not just load balance based on like memory or CPU or something, which are pretty, for our type of workload, fairly naive ways to load balance. We usually have like 30,000 containers in a cluster, so we want to load balance based on the number of containers mixed with the amount of CPU and memory usage on different nodes. So this is pretty good. Let's just do this. The event data that you send for a partition is always stored in the same blob, so I mentioned that. So that's how we're getting data consistency. We're actually borrowing storage to do that. So that's, again, I mean, there's no secrets there. That you could be using the same stuff. A little more detail, though, is that our Service Fabric service is stateless, and that's kind of an important statement, especially at the volume that we use it at. Our state is elsewhere. It's really in storage. We do some things that aren't in blob storage about indexing and stuff just for our use. We've looked at things like local storage. We just don't see a real big benefit in it. Blob's working really well for us. So why do something if we don't have to? We do have the custom load balancing stuff. This is easy. I don't know if anyone from the Service Fabric team's here for this. If you're interested in it, talk to me afterwards. It's pretty cool stuff. One of my favorite parts. We use upgrade domains to control how we roll our updates. So that's old school cloud services stuff. We've got 8 upgrade domains, which is kind of an odd number. It has to do with how many servers we put in a cluster, and we'll talk about that in a second, too. Importantly, we never redeploy the service. We only upgrade it so that we don't lose that stable IP that you can connect through. So if we just redeployed the cloud services, it would kind of throw away everything. We'd start over, at least from the networking side. And the cool thing is, since we've got this front-end and back-end architecture, even if we load balance or even if we roll updates or things like that, since you're talking to the front ends, you don't really know if we move the back ends around. So you won't really see anything happening even when we're rolling an update. So that's part of how we can get such good availability numbers. So here's a really good question, and I've had a few people ask me this. Why don't you just use storage yourself, right? If you're writing something, why don't you just use storage? There are a lot of times when you should, especially if you're writing big data, because people like to ask me, well, why do you limit the size that I can write? And it's because event telemetry is one thing and files are another thing. If you need to store something that's 100 megabytes, it's not a piece of telemetry, it's a file. And we already have a good service for that. It's a service we use, and you should use it too. But really, what we're doing to make this different workload, which is a lot of small things, work with something that was designed, like blob storage, for fewer, larger things, is that we're doing some very intelligent, aggressive batching on the back end. So the more you send, actually, the better our efficiency gets. We don't wait to do batching. It's just something we do opportunistically. We shard across a lot of storage accounts. So usually I think the number is about 50. We cache data, and we cache it in a very specific way where we put it in a cache, so if you're reading in real time, the data will actually be on the server. But we don't let you read it because your senders and your receivers are disconnected from each other. We don't let the receivers read the data until storage tells us that it's all saved, because that avoids what's called a dirty read. So if we did that, you might have a situation where a machine restarts and the reader got some data, but now that machine restarts and the data was never persisted. So if you read it again, you'll get different results. And that's not what we deliver as a service. Once you read our stream, you can go back through it as many times as you want. You'll always get the same results. You'll always get the same data. And then we read ahead to make it faster. So like I said, if we cache into memory and per partition, and if you're reading and kept up, then you're reading out of memory. But if you come back and open a second reader that's an hour in the past or something, we're not just going to read the little bit of data there. We're going to read a chunk ahead, because the whole idea is that really it's like a tape. You're going to a place in the tape and hitting play. And we know you're very unlikely to go to individual spots in the tape, because we don't give you an indexing capability. So you can't like say, hey, I just want the spots in the tape that have X. Doesn't work that way. You have to read the whole thing. So that gives us some good efficiency by reading ahead. So what this looked like when it launched, this is interesting. We were using A-series compute at the time. We had 64 front ends, 64 back ends, about 50 storage accounts, and not so much SQL, but it is all premium SQL. But in these stamps, we had a lot because of our service bus basic and standard messaging runs on the same cluster and also uses SQL. It uses SQL heavily for its storage instead of blob. And in this configuration, what we were able to do was 1,000,000 1 kilobyte events per second per cluster. So pretty good. We benchmarked that over a 24-hour period. We want to make sure it's real easy to do 1,000,000 somethings for like 1 second or 10 seconds or something. But if you can do it for a day and nothing's falling down or smoking, you're in a pretty good place. When we tested this, we actually, I think it was because we actually looked very heavily at using Kafka ourselves, which we don't. We actually did the stress testing from a bunch of Linux machines. And what we found is that an A9 can generally run about 160,000 messages per second sends per A9. And so we're using a set of A9s to do that. We have changed some stuff since then. That's a nice thing about running a PaaS service, is we're changing it all the time. Unlike running your own software, we are constantly adding stuff, constantly tuning stuff, and constantly trying to get more out of it. One of the things we've done is that we've learned from looking at our own telemetry that fewer larger VMs actually works better than more smaller VMs. And you know, these are decisions you have to make very carefully and look at a lot of data to understand the real impact of. But that is what we've come away with, so we've started to make changes that way. They also tend to be more cost effective. I know we run a lot of cores, I'll just be clear about that. But when you run a lot of cores, you start thinking in terms of cores. But if you think in terms of VMs, it's easier to actually do the math and see what's different between like a D2 and a D12 and a D15. So somehow Azure's tending to give discounts based on bigger machines. So we've moved some of those. The D-series V2s are pretty awesome machines. We're using those everywhere now. They have increased our throughput a lot. Just upgrading from A's to D's on similar kind of size, but different generations and capabilities of hardware, increased our in deployment capacity footprint by about 200%. Like same number of machines, able to do about 200% more load through them. We did have to do some funny tricks to do that because cloud services don't support upgrading from A to D. They do. We just don't tell you about it. So yeah, that might become a public feature at some point. Sorry? Yeah, a little bit. It wasn't that bad though. They don't because of the different sizes of disks and what can happen. But since our service is totally stateless, we don't care. So I mean, if you don't care about the disks on your VMs, that's fine. But most people aren't in that place. We did recently do some stuff to start changing this, though. One of the things we did was split up namespaces. So when you look at what we offer in the Azure messaging stuff, we've got 3 services that we talk about a lot. Service Bus, which is like queues and topics, Event Hubs, and then Relay. They used to all run on the same stuff. And what was it? I think a year ago, the growth rate for Event Hubs was 1,400% year over year, and which is how we're at 4 trillion a week now. and the growth rate for messaging was like 240 or 300%. Still really good growth, but not as fast as what we're doing for Event Hubs. So by putting those all in the same clusters, we were really kind of having to play some hard games about how do we get the best optimization. And now that we can deploy, we're doing this namespace split, we can deploy one without the other. So what does this really mean? If you're using any of our stuff now, what it means is that going forward, because this actually happened a month ago, you cannot create one namespace and put queues and topics and Event Hubs in the same namespace. If you have these, we will let you know about it, why we're doing it. Like I said, for one, it's an efficiency thing, and for the other, now we can deploy the services at independent rates and innovate on them independently as well. So we have some really fun stuff coming up for messaging. It's easier to do when we don't have to worry about messing around with Event Hubs to do it. Impact, you won't really see big impact. If you have namespaces that are mixed like that, they'll still work today. If you still have them soon, now that we're starting to kind of migrate people over, you will get a notification about it. And we did release a blog that I guess I should have put like an alias on here to make that easier to read. That'll tell you more about this. It's on the Service Bus blog. You can get details about how this might impact you as a customer. There's no cost impact, so it's just an organizational thing. And then one of the last things that I wanted to bring up on this is that we did do client redirect. And client redirect is something kind of cool that AMQP gives us. AMQP is the transport protocol we use. We internally, natively use a binary transport protocol that is an open standard that we like. It gives us a lot of capabilities that just aren't there in HTTP. Like HTTP 1 and 1.1 are pure request response protocols. So when I send a request out, socket's there waiting and blocking until the reply comes back. You can't multiplex over HTTP. HTTP 2 will change that, but Google's really the only one using a lot of HTTP 2 right now. I'm not going to say anything about Windows Server. Never mind. Windows Server 2016 is really cool, so this will change how much HTTP 2 Microsoft uses in our own stuff. HTTP 2 does allow multiplexing, so it's pretty cool, but AMQP has been allowing it for a long time, and the protocol we use gives us really good flow control, which if you really want to know about, it's an awesome subject, and we can talk all day about it, but it helps us reach those density numbers that I was talking about. So this client redirect is one of the things that we jumped onto AMQP to use, is that when you connect to that front-end gateway role that I mentioned, the first cloud service role, what we're doing is forwarding your request to the backend that owns that partition. What this does is that for certain scenarios, meaning if you're reading or if you're doing a partition send, what we're actually going to do is reconnect you, send a redirect command through your client to the individual machine that's hosting that partition. And this cuts out one hop in the latency chain. So this is just for partition readers, meaning you have to hook up to the partition anyway to play the tape, or for people who choose in a way to send in a way that I'm not a big fan of, which is to send to a specific partition. There are reasons to do it, but they're not that many. After initial connection, the redirect happens. You won't notice or see a thing. If there is a outage, like a service fabric rebalancing thing, the channel will drop, but the clients, the AMQP clients, are smart enough to do a reestablishment of the channel anyway. So you won't see anything from that, and importantly, it's just for these two roles, these two sort of direct partition readers and senders. And why are we doing this? It is because milliseconds matter. We do have customers who don't like the 50 milliseconds. They're like, wow, that's really slow, which makes me scratch my head, because for something that's triple replicated, that's quite fast. Especially at scale. And then the engineering manager who runs all of our messaging stuff, who's sort of the brains behind it all, he actually told me to put this in, which is that receivers being redirected is how God intended for Event Hubs to work. It's just not something we shipped with the original product. It took us 2 years to figure out the right way to do it, and this helps us with efficiency on our side. It certainly helps with efficiency on the readers, because the data is being owned by one computer. I guess the data is not, but access to the data is being controlled by one server anyway. So redirecting to that one server takes out the chain of people you need to talk to do it. So this was Cesar's thing. He loves this quote. Real quick, before we change directions a bit, I want to talk a little bit about how we organize the team. It's actually a very small team. You might be surprised to know the whole messaging team is only like 30 people doing all that traffic and volume, and that's developing and running the service. Granted, we get a lot of help because the organization, because Azure helps us with things like support, with things like billing, with all this other stuff. But the core product team is quite small. There are 3 primary engineering teams. One is focused purely on event hubs, and it's a subset of those 30 people. One is focused purely on messaging. Then one is really focused purely on, I guess the easiest way to say this externally would be DevOps. But they're the team who's really focused on our efficiency, on our runtime, on our deployments, and then things like our portal and other stuff. So we heavily leverage the DevOps idea. Everyone in the team has to do things like take rotations for on-call. I'm a program manager, so I don't have to do that, which is good for all of us, especially me. But everything they do, it's all automated deployments. It's all flighted. We have, I don't know, probably, I know the number, but I won't say it, of how many hundreds of clusters we have around the world. And it's not like we just push an update to all of them all the time. It often takes us up to 2 weeks to safely roll out everything because we just want to see how it's working in different places. We're getting smarter as Azure and both as our team in particular about this. In the past, some teams, including this team, at times would just deploy to a region that wasn't heavily used to see if anything broke. The problem is, problems might not show up in a region that's not heavily used. So it's a counterintuitive thing, right? It's like, why you're making a mistake if you're doing the simple things. So that's kind of a big one. It actually reminded me of something I was reading on the incredibly long flight here, which gave me some opportunity to catch up on a lot of reading, which was about a math theory about how the U.S. armored their planes during World War II. And the generals in the Air Force were counting bullet holes in different sections of the planes, and they were saying, oh, we need to put more armor where there are the most bullet holes. And a mathematician who was working with them said, no, you need to put the armor where there are no bullet holes, because the planes that come back with bullet holes are a limited sample of the planes that get shot. The ones that get shot just don't come back, in the bad places. It was counterintuitive, really, really clever, really slick. And I was like, wow, that is a perfect way to talk about safe deployment. Safe deployment's important stuff. So one other thing I do want to talk about a little bit is the Kafka thing, because people do know it's out there, and that's great. We actually broke up the team ourselves and tried it out before I joined and before we released Event Hubs to see would Kafka be a good tool to run this with. Before we really talk about that, Kafka is an open source software you install and run. I like to show something like this to talk about what are you, or what am I, responsible for. When you look at something like on-premise, IaaS, and PaaS, you can actually extend this on to things like SaaS. And so you have stuff that you're responsible for in blue here, you as customer. Application, operating system, virtualization, hardware, network, physical security, electricity. I mean, things that are, stuff you are responsible for. When you're moving to IaaS, you're actually shaving a bunch of that stuff off already. And then when you're moving to PaaS, you're actually taking a lot of that away as well. And not just operating system, but patching the operating system, patching the actual application, in this case Kafka, something like that. A good way to think about this is in PaaS, there are things we do, and if you're not using PaaS, there are things you do. And it doesn't matter if you're using IaaS or if you're using on-prem. You still have to do OS patching. You still have to do runtime monitoring, so load balancing. This is kind of a tough thing for Kafka, as all partitions are created equally in Kafka, or treated equally. There's not a lot of this active load balancing that Service Fabric gives us. Software patching, that's a whole lot of fun. And then continual improvement. So like I said, we have a small team, but we are constantly looking at it. So when you look at software versus real PaaS, or PaaS versus software, I should say, there are some subtleties here that different organizations look at a little differently. PaaS is fully managed on your behalf. It's not just installed. So if you look at platforms like, and I don't mean to be picking on Amazon, but if you look at Elastic MapReduce, it's very useful. It's standing up a Hadoop cluster for you, but it's just standing it up. Managing the cluster, managing the load balancing, patching and updating stuff is your responsibility. So they've made it much easier. This is a great help, but it's not taking away all the problems. They don't do the load balancing and all that stuff. So downloading software, I like to use pictures that I take usually. Looks like this. Downloading software. Okay, hey, yeah, I want a garden, right? Here's some seeds. Here's some dirt, like some land, and some tools, and have fun at it. It's great. It's what we've been doing for thousands of years, right? You get to PAS, something like EMR, you get something more like this. So you're getting, okay, here's a garden, you just take care of it now, which is cool. I have another friend on the team who bought a home recently that has a beautiful garden with all these plants and edible plants and fruit trees and everything in it, and he's having a very tough time taking care of it. So I probably shouldn't have said that. I'm going to embarrass him now. You'll never figure out who it is. When you look at something like PAS, though, real PAS, and I did use this image earlier today, but I like it. It's relaxing. It's Kyoto. You're getting something like this, something that really is just done for you. No one has a garden like this at home. Like this is a team of gardeners who come and take care of this. If you have a garden like this, that's great. I'd like to see it. But like this is a service, right? So that's how this totally works. There are also some important differences to keep in mind with things like durability. The Auth0 folks, a lot of cool, smart people over there, a lot of former Microsoft people over there, and one of them in particular, who was very highly respected in Microsoft, had this to say about durability with Kafka, and he wasn't saying something about Kafka versus like Kinesis or Event Hubs. He was just saying something about Kafka by itself, and that's that in practice, setting up and running a real HA deployment of Kafka and Zookeeper, which is required to keep it running, was just an unending battle. He has a really good blog about this here that I've linked to for you to go look at. It's interesting. I mean, when smart people have trouble running something, it tells you there's some challenges. And that's not to say that there aren't opportunities to use this. Like I mentioned, all of our data is triple replicated. If you're doing telemetry data that you can afford to lose, it's not worth triple replicating it. Like it's not worth paying to triple replicate it. So Kafka will give you that choice. We don't. Scale differences, they're really not that different. We've had a chance to look at quite a bit of this, actually, because the Kafka folks are starting to be more frank about what they use. And if you know, Kafka was started by a bunch of people at LinkedIn. We have some friends there now, like all of them. And actually, a really funny story is the engineering manager who started Event Hubs left and went to LinkedIn, ran the messaging team at LinkedIn, and now is, through acquisition, coming back. So he knows all about Kafka. This is a good example from Netflix, actually. They're a pretty heavy user of Kafka, and this is giving real numbers. So they have a cluster that's doing 550 billion events a day. That's kind of at the scale we're running. They're at 8.5 million events per second and peaking up to 22 gigabytes per second. So this is, Netflix is a very sophisticated company. The way like they make their TV shows and stuff, like I think House of Cards was the first one that people talked about for this. They looked at the telemetry of what people watch in other TV shows and what they like and don't like, and they made the show around what the numbers were telling them that viewers want to see. That not completely, but that was like a piece of what they did was big data analysis. So they're tracking a lot of stuff. Petabyte a day, apparently. They do have 12 clusters to do this across 3 regions. It's 2,700 servers. So this gives us a really good indication about the density that they're being able to get. There's a cool slide share on here about Keystone, so they call it. So we can see kind of where are they in relation to us, and it actually turns out more favorably than we thought it might be. So that's good. And if you go look at actually the Kafka's own documentation, you'll see some fun stuff. This is all taken right from that page. They say that, like at LinkedIn, one of their busiest clusters, it has 60 brokers. You could think about that as our back-end nodes. Kafka doesn't have a concept of front ends, so you actually have to know the IP of the partition you're talking to, the machine hosting it. They have 50,000 partitions on it. This is an important one. It's got a replication factor of 2. That actually means that you're going to lose data over time. You might not know you lost it, but you will. 3 is the safe place. But it is doing 800,000 messages a second in and 300 megabytes per second inbound. So this actually was a pretty happy feeling for us in our dedicated capacity units that you can purchase. We have less servers and do more, so I'm pretty happy about it. And again, there's stuff here that you can go look at and see about it. We do use Kafka within Microsoft in quite a few places. It's around. The Bing Siphon team does it, and they're pretty open about what they use with it and how it works. They have 1,300 Windows machines set up. Their peak is 1.3 million events per second. they're running Kafka on Windows, which is a sort of unusual thing. It's usually a Linux thing for some good reasons about the way the JVM supports zero copy on Linux that it doesn't on Windows, unfortunately. And even the Siphon team, they know Kafka very well. They themselves say that Kafka load balancing is hard, that it assumes that each topic is equally weighted. You have to decide where the workload goes. So if there's a reassign tool within Kafka, but it's a tool you have to use to reassign which servers own which partitions of data. So that's kind of tough. These people, Siphon team has a good presentation from this year's Kafka Summit that's worth looking at. So it's worth knowing more about it. And then kind of to wrap up on some of this is there are a few things that you should read about Kafka, whether you're going to use it or not, and whether you're going to use Event Hubs or Amazon Kinesis or something. And that is quotas. This is new to Kafka 0.9, and I can definitely see why. You could look at Parsley, had a big outage about a year ago based on how they were growing Kafka without quotas. What ended up happening was they saturated their reads, because they were reading a lot of times, sending once and reading like 10 times, saturated their VMs, the network layer. The first VM crashed, and then every other VM was right below the red line of network saturation, and after the load was redistributed from that one VM, they all were just blown off the network. Your car has a red line limiter for a reason. It's so you don't blow up the engine. And we've had that in Event Hub since day one. It is nice to see that it's being put into Kafka now. They do have some interesting stuff about availability and durability guarantees and unclean leader election, which as an American we can tell you all about right now and see how that goes. Leader election is a very specific thing about distributed systems. It's cool stuff to read about how Kafka does this and makes assumptions about it. It's more interesting than our election, at least. So summary here. The one thing I can say for sure, with certainty, is that Amazon and Microsoft are the two undisputed leaders of cloud computing. You really don't have to take my word for it. Ask Gartner. Look at the latest Magic Quadrants. Do not trust me. I work for Microsoft, so I might have a biased opinion about this. The interesting thing about this, and I know the me of AWS, is that neither of us used Kafka to build our streaming services. So that's interesting. When two cloud providers, granted we are geographically close to each other, both independently decided that we were going to use a different approach to offer this as a service. So it's interesting. It's interesting to see what we've chosen and why not. Before I finish up, I do want to remind you to fill out evaluations for this. This helps me figure out how to be a better speaker and if I'm communicating concepts correctly. And now, because I put a photo of him in every presentation I do, here's Seamus, and I'm ready to take questions. Yes, any questions on how we're using Azure, how we're scaling, what's been good or bad, or anything I said that didn't make sense? So that was a perfect presentation. I'll let you all know that I may be standing between you and very soon, I guess one more presentation and happy hour, but you are standing between me and vacation. So any questions that aren't happening in the next 1 minute, we'll wait another week before they get answered. Again, feel free to contact me anytime if you have questions, or reach out to the Ask Service Bus alias, and we will get back to you. Thank you very much for being here, and thank you for having me back at Auckland.